Scan modes. Scan mode 1, Quick Scan. Click to enter the Quick Scan interface. In the lower left corner of the screen, there is a key function prompt, which is automatically hidden when the measurement starts. In Quick Scan interface, move the instrument slowly and evenly to the right. A real-time displacement value appears at the bottom of the screen. When the instrument is in the middle of two rebars, the aiming box is in blue. Move the instrument continuously. When the aiming box and the centerline overlap, the aiming box turns red, while the red indicator light lights up with a buzzer alert. The longitudinal laser light of instrument emits a red vertical line, and the thickness of the rebar protective layer is displayed at the bottom of the screen. It indicates that the instrument detects the rebar at this time, located directly below the red line. When the scanning distance exceeds the range displayed on the screen automatically turns the page. Or you can press left and right keys to flip through. During the detection process, if it is found that the thickness of the rebar protective layer is abnormal, you can retract the instrument to re-measure. When the instrument is retracted to the left of the measurement point, the system automatically eliminates the measured measuring point data. Note, when auto appears in the upper left of the screen, the thickness value of the protective layer is automatically saved. Press OK to change auto into manual. If you set to manual storage mode, it is necessary to press FN key to save the thickness value. In this way, at the bottom of the screen, the thickness value appears. At the upper right of the detection interface, there is a detection limit setting to avoid the instrument scanning and identifying deep rebars. This parameter does not affect the detection data. Scan mode 2, Procedural Scan. Click Procedural Scan to enter the scan mode screen. There are 6 types of procedural scan modes. You can select the detection mode according to your detection needs. We take single rebar 3-point retest as an example to illustrate. Select the scan mode to enter the detection interface of procedural scan. In the middle of the screen, the detection step prompt box pops up. The line represents a rebar, and the dots on the line represents the part. Each point has 3 states. The blank represents the part to be detected. The blue represents the completion of the first data acquisition for that part. The green represents the completion of the second data acquisition for that part. After you enter the scan, the prompt box disappears. When detecting, move the instrument slowly. Until the instrument is moved above the rebar, the interface displays the current thickness value. At this time, press FN key to save the measuring point value. Then, on that part of the rebar, perform a second scan. After the 2 measuring point values are stored, the instrument automatically calculates the average value of the part. Repeat the above steps. When all 3 parts are measured, the instrument automatically calculates and displays the average protective layer thickness of the current rebar. When performing multi-rebar 3-point retest, continuous scan is required. The detection sequence is performed in accordance with the sequence of priority rebar, and then in accordance with the detection parts in turn. That is, to get the first thickness of the protective layer of the part 1 of all rebars, and then to get the second thickness of the protective layer of the part 1 of all rebars in sequence. After testing the part 1, press OK to get the first and second thickness of the protective layer of the part 2 in the same way. And the first and second one of the part 3 in turn. Scan mode 3, Wave Scan. The Wave Scan mode displays the detection information of detected rebar in real time, in the form of waveform graph. In Wave Scan interface, move the instrument slowly to the right to start measurement. In this way, the screen slowly displays the signal wave, and the real-time displacement value at the bottom left of the screen. When the instrument is close to the rebar, the signal value starts to increase and the waveform curve slowly rises. When a wave peak appears, the thickness and position of the rebar protective layer are determined simultaneously. At this time, at the peak of the waveform, a white line appears to indicate that there is a rebar here, and above the peak of the waveform, the thickness of the rebar protective layer appears. In the lower right corner, when the aiming box and centerline overlap, it indicates that the instrument detects the rebar at this time, located directly below the red line. When the instrument is away from rebar, the waveform decreases gradually. When detecting multiple bars, the instrument automatically calculates the rebar spacing and displays it below the waveform. When the scanning distance exceeds the display range of each screen, the instrument automatically flips the screen to display, with a maximum support of 10 meters scanning range. Scan Mode 4, Fine Scan. The fine scan is specially designed for the special scanning scenarios such as high and low rebar and dense rebar. If there is a distribution of dense rebar spacing, press the right arrow key on the detection interface to switch to the dense rebar mode. In this mode, the scanning speed should be uniform and slower, and the waveform signal becomes smoother and wider than the waveform of a single rebar, so the instrument needs to combine the changes in waveform before and after to determine the rebar position. So there may be a delay in interpreting the rebar position. Press the right arrow key again to return to the fine mode. Scan Mode 5, Grid and Image. It is divided into Grid Scan and Image Scan. Grid Scan is a measurement mode that displays the position of the measured rebar, the protective layer thickness and the rebar spacing, in the form of a grid diagram. Through the grid diagram displayed by the grid scan, the user can see the arrangement of the rebar. When entering the grid detection, first, the grid horizontal scan is performed by slowly moving the instrument. The bottom left position of the screen begins to record the displacement. When the rebar is detected, the instrument displays the measuring points of the rebar and protective layer thickness in the form of grid lines, and calculates the spacing of adjacent rebar. When the horizontal rebar scan is finished, press OK to switch to grid vertical scan mode for continued detection. Press C to save the data and exit the grid detection after completing all detection. Image scan mode is a measurement mode that combines fine scan and grid scan to perform comprehensive analysis by scanning horizontally and vertically in a specific area, which is suitable for the measuring environment with irregularly distributed rebar. In the image scan, users can scan in a maximum of 2 multiplied by 2, 3 by 3, 4 by 4 and 5 by 5 grids. 2 multiplied by 2 means 2 horizontal scans and 2 vertical scans, of which the scan position can be selected arbitrarily. After scanning, press C to save the data. After completing all data collection, users can import the data into the computer for data analysis. At the same time, 3D graphics can be generated to display the distribution of rebar more visually. Scan Mode 6, Complex Conditions. Complex conditions are a detection mode developed for the site's special environment. 1. Exclude stirrups. Stirrup avoidance detection can be done without considering the spacing, diameter and position of stirrup. This detection mode is suitable for the scenario with sufficient bar spacing. Besides, the scanning sequence of initial rebar is from the left to right, which is consistent with quick scan. 2. Convex surface detection. Convex surface detection is appropriate for longitudinal rebar detection outside the pipe of cylindrical components. Entering the diameter and basic parameters of the cylindrical component, in turn, can start the measurement, with the instrument automatically correcting the error caused by the surface arc. The diameter of cylindrical components can be set to a minimum of 130 mm. 3. Concave surface detection. Concave surface detection is appropriate for longitudinal rebar detection inside the pipe of cylindrical components.